Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, as we are kind of starting this fall school year. And I'm actually doing a review with my classes here, specifically within Integrated Math 2 class that kind of touches on some kind of intermediate Algebra 1 and geometry and stats. This is more on just the algebra focus. I'll go ahead and give you a preview of what we're looking at here as we do a practice test. I just made another video right before this one that's a review of this stuff. It's example problems as well, and it's a different set, but I do a little more teaching there. You can, it's a 52-minute video, so I explain a lot more. I show you, how you don't mess up and alternate ways to do something right, and I kind of talk through it more and more. So on this practice test here, a lot less of the teaching, a lot more of the doing. And what I plan on doing here, look at the sections, by the way, in these two modules. Analyzing functions, domain, range, and behavior, intervals of increase, decrease, where are the intercepts, things like that, that might come into play. And graphing and solving absolute value functions either as equations or inequalities, which also possibly means graphing them on a number line, graphing them on real axes, things like that. So keep that in mind, those are coming into play. So as a practice test here, I plan on kind of having a PDF. If you go down below to the description section of this video, I'm hoping that I would have been able to provide you a link to a PDF of this actual practice test. And this is really a front backer that I have on here. It has graph axes on them for the problems. And you can then print that out and follow along with me if you'd like to, or of course you're just watching it and taking hold. And also in the description section below, I'm going to provide timestamps for you for each problem that I do, especially if you're following along in the PDF, because it could be scattered. I haven't done this yet for myself. I know the material, so we'll see how it goes. And like I said, this video is less teaching, more doing. I'll talk through them, but I'm kind of going under the assumption that you kind of saw the other video, or that you know enough from what your teacher saw that you're just trying to see how to get this one started, how to make sure you don't make a mistake. But again, a lot less teaching. I want to forewarn you on that because the other one's long, because I spend a lot more time on it. I slow it down. This one should be significantly faster. Should be, because as a teacher, I tend to teach. All right, so let's go ahead and get started with this thing here, guys. Practice test. Get on up. Now, by the way, try this for yourself first. If you have it, try it for yourself first, and then check out number 1 with me. And then try number 2 and check it out. Try it first so you see where you're at before that. At least with the review, because I had a PDF for that one hopefully as well. At least for the review, maybe you're learning it with me for the first time. And this time, check for yourself. Where do you stand on this? That's how I'd kind of go with this material. All right, let's go ahead and look at this. And this is that full first page right here, looking up and down. So your page should look just like mine, only maybe you can write your name on top, things like that. So let's get started. For numbers 1 and 2, write the domain and range as an inequality, not interval notation. Also describe the end behavior. The end behavior part's down here, domain and range is up here for numbers 1 and 2. Okay, number 1, we have this parabola upside down facing, and like I said, a lot less teaching here. Domain is in reference to the x values. As it goes down forever, it is also going left and right forever. Don't let the arrows mistake you into thinking it's going to go straight down at some point. You'll still find x values even at negative 100, then it'll go there. As an inequality here, we would really put all real numbers, that's fine, but you could also put from negative infinity to positive infinity as a compound inequality like that, because there is no end range for x. We're not stopping at some point, so you can do either or, and they would both suffice. The range, it looks like it goes as high as 0, and then it goes down forever. You don't have to put the negative and positive infinity if you do have a specific boundary endpoint here, and we do at 0. It goes as high as 0, and it includes 0. So we get to say y is less than or equal to 0. That is as an inequality. There's my domain and range. End behavior is talking about as x goes forever to the left and right, what's going to happen with y. So as x approaches negative and positive infinity, what's y doing? As x goes forever left, it looks like your y values go forever down. This parabola keeps going down like that. And same with the right side. So as x approaches negative infinity, y approaches negative infinity, goes down forever. And as x approaches positive infinity, y approaches negative infinity, because it also goes down forever to the right. So there we go. And compared to the last video, you'll know this was a lot less teaching. It was explaining why I answered what I did though. All right, so this second one right here, this is called an exponential function. This is not actually a parabola. Don't assume this is going to go back up again. It's not. It's actually approaching what's called an asymptote. An asymptote is this kind of boundary line that says this thing will never cross or touch it. It will actually never approach this line. This graph gets so close to the x-axis. So super close. Fractionally so, but never actually hits it. And that's important when we talk about range and end behavior. All right, domain. This does go forever left. You can see the arrow there. And it does go forever right. It goes sharper up, but it goes forever right. Domain, once again, is all real numbers. All exponential functions should be doing that don't have any sort of hole or discontinuity. So all real numbers, or of course from negative to positive infinity on x as an inequality like this. You might be wondering why I'm not putting the greater than or equal to's, things like this. Because, oh my gosh, just that one undo did that. Because we don't reach infinity or negative infinity. Those aren't numbers. They are just endless bounds that we approach. Will always be greater than negative infinity because we can't ever reach negative infinity. Range right here, it does go up forever. We go up forever as we go to the right, but as we go to the left, it starts shrinking and shrinking and shrinking. And like I said, it never actually crosses this guy right here. I made the dotted line to make sure you see a little more. That's called an asymptote. It's approaching the x-axis. It's approaching 0, but never touches. So we can have y value be any positive number toward infinity, but it never hits 0 or negative. So y is actually just greater than 0. Never actually hits 0. That's probably something that's saved a little. Maybe in later Algebra 1 we hit exponentials. I'm trying to remember. But Algebra 2, it's definitely, you're going to look at more exponential functions with those, and you'll really learn that. All right, end behavior. As x approaches negative infinity, y is going to approach, let's actually save that one for 1 sec. Let's do the positive infinity first. As x goes forever right, y is going forever up. You can see that one clear as day right there, right and up. As x goes forever left, remember, it never touches 0, but these arrows are not saying what it equals. It says what it approaches. Y is approaching 0. It can never equal 0, but it's getting super close. That is a limit. As x approaches negative infinity, y is approaching 0, and that is okay to state. All right, that was numbers 1 and 2. Let's go ahead to number 3 and 4 now as we have inequalities. Again, less teaching on my end here, but I am going to do. Let's solve this guy algebraically, and then we're going to graph that, showing all work, meaning show these steps. Gladly, I'll go ahead and do that. So I'm going to subtract 4 from both sides right here to begin with, and we are going to now have 3 times the absolute value of x minus 2 is less than or equal to 12. 16 minus 4. Let's get the absolute value quantity all by itself. Let's divide both sides by 3 here, and we are going to get the absolute value of x minus 2 is less than or equal to 4. Again, a lot less teaching here, so you got to go back to the review one if you want to see questions on what I'm about to do here. I'm about to split this up in 2 different inequalities. If we're less than or equal to positive for an absolute value, this can either be less than or equal to positive 4, or, and really the words and it has to also then be greater than or equal to negative 4. Again, less on the teaching, but we are staying within 4 units of 0 on either side. Add 2 to both sides here, and we're going to then get x is less than or equal to 6. And if we add 2 to both sides here, do you have to show me adding? Yeah, I'll go ahead and add 2 here. I might skip some of those steps sometimes if I feel like it takes a while. I got to write all this stuff. They did say show all work. So x is greater than or equal to negative 2. Now the and is important because we got to stay within these sets here. Greater than a negative, less than a positive here. That makes sense. You could also write it as negative 2 on the left here is less than or equal to x, is less than or equal to 6. That's another way of that compound inequality showing up in a nice way. I'm going to go ahead and graph this now. Negative 2 is my end bound on the left. I'm going to draw a closed circle because it's also or equal to 6, the rightmost end bound right here, and x is anything in between. You can try and plug in numbers and see if it works. 0 should be a solution, as anything in between negative 2 and 6 should work. Anything outside of negative 2 and 6 would not work or satisfy the original inequality. Okay, I'm moving on to number 4. Here we go. Number 4. We got a fraction in front. We'll deal with that as we need to later. Don't get too bummed out by it. It's going to go away pretty fast. And we're not going to be too bothered by the idea of common denominator or anything like that. So that's no problem. I add 1 to both sides, and I'm going to get greater than 5. 4 plus 1. 1/3 times something also means that's something divided by 3. So 3 is dividing right here, so I actually can just multiply both sides by 3 like this, and I will take care of the fraction easy peasy. 3 over 3, just like right here. That's a 3 over 3 right there as well, right? They cancel, fraction be gone, 5 times 3 is 15. So the absolute value of x plus 1 is greater than positive 15. This time it's a greater than in my absolute value, not a less than. So this time it's not going to be an and, it's going to be an or. And as we split it up here, because the greater than means staying outside of 15 units of your number. So either x plus 1 is greater than positive 15, or x plus 1 is less than negative 15. Again, staying 15 units outside of 0. Now, what is x? Subtract 1 from both sides. We get x is greater than 14. Again, trust the process. Subtract 1. Or subtract 1 from both sides. X is less than negative 16 right there. Again, negative 15, use a calculator. Minus 1, we go further, negative, less than negative 16. We can't use this compound inequality format with an or situation. This is specifically for a within something, so it's an and case. So we got to leave it like this right here. But let's go ahead and graph that. And this number line is not very helpful for it. So I'm going to trust that I did this right. Let's see, times 3 and then plus 1. It looks good. So they're not really there. Let's just pretend. I'm going to go a little farther off. Let's just say, hey, guys, here's 14. And hey, guys, here is negative 16. Is that okay? Let's say it's okay. So in purple, I'm going to draw open circles this time. Open circles meaning that it does not include these points. There's an arrow way on the right there. It's hard to see. There's an arrow on the left here. These are my values of x I can have. There and there. Anything in between negative 16 and 14, including negative 16 and 14, do not work. Anything outside of them do. There's my graph. Sorry for the number line, guys. That was not my pre-creation. I did not make this worksheet. So sometimes there are mistakes. And I'm not saying my worksheets don't have mistakes, but I am exonerated from blame. All right, so let's graph each function here. These are absolute value functions. I will provide this thing for you right here. This is the absolute value graph model. That's an A times x minus h in the absolute value set plus k. A is your stretch factor or your slope for absolute value functions, and hk is your vertex. But again, less on the teaching. That's just what I'm using, so you know. And h will be opposite of what you see. If it's minus 2, that means h is positive 2, right? Minus h. So my vertex here is going to be at 2, and then k is the same, plus k minus 3. That's plus a negative 3, so k is negative 3. Opposite same. I'm going to start my vertex at 2, negative 3 right there. My vertex is at 2, negative 3. And then my slope here is 2/3, positive 2/3. So I'm going to rise 2, run 3 in both directions here to get my v shape of this absolute value function. This is shorthand notation, but that is how it works. And because I said I am going to do less teaching, more doing, here is my doing. Hopefully you're keeping up. And of course, this is a video, so you can always pause me and rewind me. But that is the graph, that is the result and answer, and I will move forward. The next guy right here doesn't have anything within x, so it's like x minus 0. So my vertex is at 0 on x and positive 3 for y. That was a negative 3 here. This is a positive 3 here. This is where I begin at 0, 3. Negative 2 means negative 2 over 1. So, and also it's a negative value. So slope is negative, meaning our v is upside down. So we're going to go down 2 over 1 in both directions. So down 2 over 1 like this. Find as many points as you can on either side to go down, just for accuracy, good precision. And you'll get a nice upside down V shape like this guy. A lot sharper than the 2/3, as you can tell. And a lot bluer too. Hey, how about that? And that is our graph right there. You can double check things. Well, this is the tableless format though. That's what I did in the review portion, and I did it here too. All right, number 7, given f of x equals the absolute value of x, that is called a parent function right here. It's the most basic form of our absolute value function. Okay, given the parent function and then this transformed function g of x right here, describe the transformation necessary to change the graph of f of x into the graph of g of x. So they're saying use words to say how do we go from that most basic form of just this thing at the origin right here to something that apparently goes vertex is, whoops, I thought it was in green. Vertex is opposite, same, and then you have a slope of -3, like down 3 over 1, and things like that, and it goes sharp like that. So how do we go from blue to green? Well, I kind of explained both sets. I'm going to talk about the flipping over part first and making it stretched, because in case you actually start this part first, you don't want to say flip it over the x-axis, because then it would go up above. So here's what I'm going to do. Hang on. Shrink it. Okay. We're going to say reflect over x-axis. That's another way of saying flipping the V shape over. Reflect over x-axis. Okay. Vertically stretch this thing by a factor of 3. Because remember, the original one technically had a slope of 1. Okay. And now I don't have to say -3. My reflection already makes that happen. I already flipped it over. Now I'm making everything 3 times taller than it was before. And finally, shift 1 left and 2 down. And then you would end up where you were right there. All right, so that's the result. Let's make it kind of a dark green right there. All right, so that's the result there. That's describing the transformation to make all those things happen. And there it is. All right, let's go and turn it over to the next and final page of this guy. It's only 16 minutes in. I thought this would be shorter. I don't know how long this whole page would be. A lot more graphing, it looks like, or things with graphs. Find the domain and range of this guy. Use inequalities, just like last time. All right, this time there are no arrows that say this thing goes on forever. In fact, it stops. And furthermore, one stops at an open circle, one stops at a closed circle. Open circle means it does not include that point. Closed circle means it does include the point. So domain on this guy, you can see this thing goes as far left as -4, not including the -4 right there, because once it hits -4, open circle. So for x here, our leftmost point, this is one of those compound inequalities I can make, is -4, and again, doesn't include it, so just less than, not less, or greater than -4. And then it's going to be reaching 4, including +4 right there, so x is less than or equal to +4. That's a good way to state that domain. Every point in between is included there. That's good. Range is a little trickier here, because range, we say how high does it go, how low does it go. Where do we see y points exist at any one particular case? And we can go, from -4 to +4 here. You see it goes as low as -4 and as high as +4. But the question here becomes, do we include -4? Because I want you to look at this. We include +4. +4, the y touches. So I'm going to say y is less than or equal to that. But is y just greater than -4? Because I see a hole here. But you see a point here where it does touch. So which one do you go by? If it exists at any point on y, it's included. So even if there are holes everywhere else on this thing, if it hits it even once, it counts. So y does inherit -4 at least once, which means you do have to include it in your range. Remember, it's your range. How low can it go? It can go as low as -4, despite the hole. Okay. Now x does not include that -4. Keep that in mind. All right, identify the intervals where the function is increasing. Use inequalities. So we're talking about as x goes forever, when is y increasing? So it's increasing, -4, it's not increasing yet. It hasn't started yet. And it's increasing forever. It's increasing here, here. And then it hits 4. It's neither increasing nor decreasing. And then it decreases here all the way to 4. So the only time when it's increasing is when it goes from -4 on x to 0. 0 on x. -4 to 0 is the increasing area right here. That's when y is going up as we go to the right. So we are saying from -4 to 0, and we do not include -4 or 0. Remember, -4 isn't a point in general, and 0 has a slope of 0. Slope of 0 is flat. That's not increasing, that's constant. So that's the inequality state that we'll say here. So intervals, we're talking about what values of x is y going up. So we don't have to talk about y. We just have to talk about x there. And find the maximum. Now we got to talk about y. For what x value is there the highest y value, but the tallest y value is at the very tippy top right there is at 4. The maximum is y equals 4. Okay. That occurs at x equals 0 if you'd like to put that. I don't think that's an important part to necessarily state there, but that's the highest y value you get. The answer is y equals 4. That's your maximum. Part D, what are the zeros? Okay, zeros are x-intercepts here, so you got to see where this thing crosses the x-axis. Let me get rid of some of this other stuff here. And Ooh, this is a problem. This is because you guys haven't done quadratics, have you? I don't know if I want to answer this. Notice here, I was hoping it would maybe cross right there at -3. Okay, zeros mean x-intercepts. Let's first answer that, just in case you do get a question like that. Where does it cross the x-axis for what x values? If it crossed at -3 and +3, that's what we'd say. X equals -3, x equals +3. However, it's not. It's hitting a fraction, and we don't know what it's hitting a decimal, and we don't know what that decimal is. Now, I'll let you know right now, when it comes to quadratic functions, oftentimes if it's not hitting an integer, it's irrational. That's not always the case, but oftentimes it's irrational. Irrational means you can't even represent it as a fraction. Irrational means you got to do more for this problem to make it happen. Now, this is possible to do, but it requires that you know what this function is and that you know how to solve things. Because it's only an upward shift, I'll solve it, guys, but you should really skip this. I don't think this would be a question you'd be asked. This graph, it's y equals, so +4, so x plus 4. X squared. So it's negative. It goes upside down. 2 okay, so it's -1/2 x squared plus 4. Okay, so it's kind of weird, but there's only an upward shift, which means you don't have to solve by factoring or quadratic formula. We have to find out for what values of x make y equal to 0. So 0 equals -1/2 x squared plus 4. If you were given this information, maybe you could solve, and that would be fine. However, leading up to it, maybe it would get a little tricky. So solve for x, I'm going to add 1/2 x squared to both sides. Then I'm going to multiply both sides by 2. And we'll get x squared, it's down here, we'll get x squared equals 8. And then we'll take the square root of both sides here. And the square root of x squared is the absolute value of x. I'm just going to turn it into x right now. Just make sure you get plus or minus these guys here. You can either put the square root of 8, or, and I'm not going to talk about this, but you can simplify this, plus or minus 2 root 2, or you can do plus or minus the irrational numbers. I don't know, 2.8 something. I don't know what those numbers are, plus or minus whatever. So any of those answers would work there. Those are the zeros. Don't expect this kind of question on your thing unless you're hitting actual integer x-intercepts there. But so what zeros are x-intercepts? What are these zeros? They're irrational solutions. I'm sorry about that, guys. This isn't my thing. I didn't know it was that. The show must go on, right? Part E, what is the average rate of change from the points -2, to 4, -4? Show your work. I'm not saying they're trying to trick you, but don't let this thing trick you more than... See if you can make sense of this. Rate of change, average rate of change means slope. They're asking what is the slope from -2 to 4, -4. What is that slope right there? That's what they're asking. That's all you gotta say. And you can use the graph to help yourself out. We're going down and over a certain amount. You might even know based on this. I kind of drew it badly, but 1, 2, 3, 4, 5, 6, down 6, and right 1, 2, 3, 4, 5, 6, over 6. Your slope down 6 over 6 is -1. That is the average rate of change from here to here. Yeah, you went up first and then sharply down second, but you averaged out, 6 miles an hour, or 1 mile an hour, 6 miles in 6 hours, whatever it is. Okay. Numbers 9 and 10, write a function that represents each graph. These are absolute value functions. It might help for me to write this thing one more time here. A times absolute value of x minus h plus k. And basically what we got to do is determine what the h and k is, the vertex, and plot those in. All right, I see my h is 2, my k is 5. And then figure out your slope, kind of just by doing what we just did last time, rise over run. We can use the graphs for that. So this is going to be pretty straightforward here. The h is 2, this is for number 9, h is 2, k is 5, and the a value, they give you another point that can easily help you here. And use the numbers to help you, because this looks like it's hitting a fraction, but it looks like it's going 2, 4, 6, 8. So this is halfway from 4 to 6, which is 5. So we're going up 1 to 6 and over from 2 to 6. So up 1 to 6 and over from 2 to 6 is 4. We're rising 1 and we're running 4, right? From 5 to 6 is 1, 2 to 6 is 4. So your a value is 1/4 there, or your slope. So let's write that out. 1/4 times the absolute value of x minus 2, opposite, plus 5, same, plus 5 there. I can turn that all blue so that you can just see that more easily. There you go. All right, and this next one here, and you know, if you have trouble counting the up and over by not being sure what that is, let's use the slope formula for this next one, okay, if that's all right for you. Let's dissect what not blue again. Let's dissect what h, k, and a are. H is 1, k is 6. That's my vertex right there. And this time for a, guys, let's go ahead and use kind of the slope formula, y2 minus y1 over x2 minus x1. Let's do 6 minus 3, that's a y2 minus y1, over 1 minus 0, x2 minus x1 there. That's 3 over 1, which is 3. So your slope, your a value there is 3. I made a mistake. Okay, well, I didn't really make a mistake, but you have to be careful here. I did the slope of this line right here. Now, that's a positive slope, right? Because I chose the thing as it went to the left of the vertex. The problem is this is an upside-down V-shaped graph. That means this will be a negative a value. So I really should have been doing the slope as it went to the right there. Then I would have gotten a negative value, but pay close attention to that. Because it's upside down, get a negative a value there. So I'm just going to put a negative 3. Hopefully you kind of get what I mean there. Upside down is negative. So f of x equals negative 3 times the absolute value of x minus 1, opposite, plus 6, same. There it is. All right, 11, 12, 13, 14. 4 more problems here. Number 11, if the parent function f of x equals x is compressed, I use the word shrink, is compressed vertically by a factor of 2/3. Hey, they use the same verbiage, so that should help. If it shrinks vertically by a factor of 2/3 and translated 2 units left, 7 units down, write an equation for this new function. All right, well, 2/3 compressed vertically, it's your slope, but it's also your stretch factor. That's what a actually is. A is, different color, a is 2/3 there. 2 units left means that your h value is negative 2. 7 units down means your k value is negative 7, because negative, negative. So let's write this thing out. That's going to be 2/3 times the absolute value of x. H gets opposite. Remember, it's x minus h. X minus h minus negative 2 is plus 2. Opposite. And k gets same. Minus 7. Same. There it is. Okay. Number 12. Nirupa was trying to solve x. Am I going? Yeah, I'm going a lot faster this time. Nirupa was trying to solve the absolute value of x plus 3, and then close it, plus 1 is greater than 4 graphically. Her graph is below. Use Nirupa's graph to help her find the solutions. Let's confirm the graph makes sense. If you saw my previous video, you know what we're going to do here is we're going to treat this as one thing to graph and this as another thing to graph. They're both y equals things, so we got to give them different equations. So y equals absolute value of x plus 3 plus 1, and then the other one is y equals 4. So let's make sure she graphed them correctly, and I'm going to go over them in these colors so I can use the colors to describe what happens. And remember, I'm not going to spend a long time teaching this one. I'm just going to say it as I'm doing it. You want to see me teach the other one, you want to see me teach one of these, go to the review video, please. And it might be the last question on there that I could do something like this. Okay, let's make sure she graphed these correctly. So vertex is negative 3, 1, negative 3, 1, and stretch factors up 1 over 1. That's good. And y equals 4. Good. Okay, we're trying to find out when f of x is greater than, here's the greater than, it's greater than g of x. We're trying to find out when blue graph is above green graph. For what values of x are blue above green? There are 2 boundary points, the points of intersection of blue and green right here. Blue is not above green at these points. Blue is equal to green here. But it separates the values when blue goes from underneath green to when blue goes above green. You can see that from negative 6 to 0, blue is clearly below green right here. But greater than 0 on x, blue is above green. Less than negative 6 on x, blue is above green. Those are our answers. Those are the ones that we're trying to say there. So help her find the solutions. What values of x make blue above green, or what values of x make the left side greater than the right side? So when x is less than -6 or when x is greater than 0. Those are the answers there. Again, you use the boundary points of intersection to help you separate from when it works. By the way, -6 and 0 don't count, again, because they're points of intersection, and more specifically because we're not looking for points of intersection. If it was equal to, -6 and 0 would also count. But they don't right here. So when it's less than 6, blue's above green. When it's right, blue's above green as well. Okay. All right, number 13 and 14. Solve. Okay, we solved this one graphically, so this is just like the Narupa problem, only this time we do it ourselves. I'll make this blue and green one more time, and it's a greater than again. I wish we'd change it up so it's not always when's blue above green, but guess what? It's not. So f of x equals -1/2 times the opposite value of x minus 1 plus 2. You don't have to do this each time. I'm just giving you that format so you can really see it. And g of x equals 1. Let's start with g of x here. It's a pretty quick one to do. It's y equals 1 horizontally across like that. And then this -1/2, all this mumbo jumbo, let's take care of that. Vertex is at opposite same, +1, +2, right here. And then you have a slope of -1/2. That means an upside down graph, down 1/2, an upside down V shape, I should say. Down 1/2 in both directions. All right, that's good. Draw the arrows, and we got to see where is blue above green. Doesn't look like a very large interval for it because it's around where the vertex is. Points of intersection you can clearly see here and here. This is when we go from when blue is underneath green, underneath. Now it's equal to green. Here's where blue is above green. That's what we're looking for. Greater than. When is blue greater than green? When is blue above it? Greater than right here. And then it's equal to when it's underneath here. So in this region right here is when blue is above green. Don't worry, I'll undo that. Now, where is that region? It's between when x equals -1 and when x equals +3. It's between those. It doesn't mean x equals -1, x equals +3. The answer, in fact, is when x is, I'll write this in two different ways, greater than -1 and x is less than 3. Again, you have to be between those two. So you have to be greater than -1 and less than 3 at the same time, any of those numbers. Or as a compound inequality, we'd write it like that. Okay? That's when blue is above green. That's when blue is above green. That's solved graphically. Let's solve this one algebraically. This is an equal sign, not an inequality. This one should be more straightforward than the others. We don't even have to graph it on a number line. Let's use kind of darker red again. So I'm going to add 2 to both sides right here to begin with. And kind of a deeper red right there. And now we got -15 times the absolute value of x minus 1 equals 77. Okay, I liked the 75 before because I wanted to divide by that. That would have been cleaner. But 77 doesn't divide by 15 very well. Doesn't look like it's going to be a big hassle. You'll see why in a moment. Let's divide both sides by -15. Don't forget that negative there. If this were an inequality, we would actually flip the inequality once we divided by a negative. But here, just make sure that your number is negative in the end. I cannot reduce that, so I'm going to leave it as -77 over 15. And you're like, well, that's a big problem. I don't want to work with fractions. You won't have to. This is a negative on this side. We cannot take the absolute value of something and get a negative. Okay, we cannot take the absolute value of something and get a negative. That means no x value can be plugged into here to help you get it equal to this because we can't get equal to it. This is no solution. This is no solution. And again, I talked about this more in the other review thing. I don't think I did it with an equal sign, but there still was a no solution case that you can refer to for the same description I just mentioned below there. And that's the final answer there. All right, so that was all of the problems there done in 35 minutes, 15 minutes less than the other one, but I think it was more work, and that dumb quadratic one got in the way, one that you don't even have to care about, so I'm sorry about that. But that was it. Ooh, look, I'm on fire right there. Perfect. All right, that'll do it for this one, guys. If you have more questions, you can ask them in the comment section down below. I hope I got those PDFs for you guys in the description section as well. Depends on what free uploading sites there are online. I got to find them. And that's it from me, guys. Take care, and good luck.